This lesson concerns factoring. We're going to be factoring trinomials. This will work for all trinomials, but especially for the trinomials that have a leading coefficient that is not equal to 1. So if you have a number in front of the x squared term, this will be important to learn a technique to be able to factor it. We learned before how to factor when the leading coefficient was 1, and that's a quicker method. These methods will work for that type of trinomial, but this one will work for all trinomials in this pattern. So our objective is to be able to factor trinomials. So I'm going to teach you two methods. The reason why you're going to see two methods is because of giving you the option of doing either one. You're going to develop a preference for one or the other. I would recommend you decide which one you like better and use it. You can use either one. They both work. It's just that usually people have an opinion whether one method works better than the other. Make sure though you decide which one to use instead of trying to use them both, because usually it's better to streamline your work and deciding which one you like. So I'm going to start by showing what's called the X method, and then I'll use the box method after that. So the X method is where you form an X on your paper, and you take the first leading coefficient and the last term, you multiply them together. You take A times C, and then whatever the coefficient is in the middle of it, what's in front of the X, that goes in the bottom here. And then we're going to look for two numbers that multiply together to give me this AC and add together to give me the B. Now that might sound familiar for how we did it with the leading coefficient of 1, but notice it's where we're going to take and not just use the C for multiplying, but A times C. That's what the two numbers have to multiply together to equal. So let's take a look at what that looks like with a problem. So we're going to look at this problem here where we've got 3x squared plus 10x plus 8. Look to see if there's a GCF first. There's no greatest common factor for this one. So I'm going to form an x here. And I'm going to multiply the 3 times the 8. So just so you know, 3 times 8 equals 24. So I'm going to put a 24 here. And then I want to put the 10 just as is right down here. Now I'm looking for two numbers that multiply together to give me 24 and add together to give me 10. Now if you listed them out, 24 times 1 is equal to 24. That does not add up to 10. And remember, these could be negative because two negatives could multiply together to give you 24 as well. But since this middle one's positive, we're going to go ahead and just use the positive ones instead. So now the next one, we could do 12 times 2. Those do not, that's close, but they don't add together to give me 10. The next one's going to be 8 and 3, getting closer. 8 plus 3 gives me 11, but doesn't equal 10. And then we've got 6 times 4. 6 times 4 is equal to 10. That's the one I want to use. So I'm going to put a 6 here and a 4 here, and I'm going to put the x's with it. Now here's the secret to the X method. What we're doing is we're taking this 10x and we're splitting it up into two different x terms. Just like when you were multiplying things together, you added the 6x plus the 4x to get it. Now we're splitting it apart. That's because factoring is splitting apart or undoing the multiplication. So list the 3x squared. We're going to split apart the 10x into 6x and 4x. And then we've got the plus 8 out here where we just bring it down. Now I'm going to do what's called grouping. Okay, grouping means I'm going to group together these first two and these last two, put them in parentheses in order to group them together. And then you're going to do like we talked about before. In each of these two parentheses, you're going to take out the greatest common factor. So the greatest common factor between these two is a 3 and an x. If I take out a 3x, 3x times x gives me the 3x squared. And then if I take a 3x out of the 6x, I'm left with a 2. 3x times x is 3x squared. 3x times the 2 is the 6x. So you distribute it out. I'm going to do the same thing here where I'm going to distribute out the greatest common factor, which is a 4. 4 goes into both of those. I'm left with an x when I take it out of here, and I'm left with a 2 when I take it out of the 8. So notice here, this is the way this works, is that I've got a common factor of the entire quantity, x plus 2. That parentheses is a common factor. So I'm going to distribute it out of the whole thing, taking it out. And what am I left with when I take that out? Well, notice this 3x and this 4 are left. I put that in the second parentheses. The 3x plus 4 is my second factor. So I've got these two binomials are the factorization of this trinomial by separating out the middle 10x into two terms that we can do factoring by grouping and take out a GCF. We'll do another example of that in just a moment, but I want to share with you the box method. That's also a viable method for doing these. The box method is where if you take, it's really an organizational tool. We're going to organize our guess and check method for trying to figure this out. So to do this for the box method, I'm going to take the ax squared, the first term, and put it in this box. I'm going to take the c and put it in that box. Then what I'm going to do is try to separate out what would these things be up here, like we had multiplied them before. How do I separate them out for these to multiply to get this? So let's try it with one of these. Let's try it with actual numbers, that will help. So 2x squared goes in the first box as I form my box here. And I'm going to put the 15 down in this box. Now 2x squared, there's not much I can do with it. Really, it's a 2x and an x. I want an x in each term. So I'm going to put 2x and x here. Now my 15, I can have 15 and 1. I can have 5 and 3. I tend to like to try the middle ones first. So I'm going to try putting a plus 3 here. And 3 times 5 gives me 15, so I'm going to put a plus 5 here. Let's check to see what that gives me in the box. So for this, when I multiply these two together, x times 3 gives me 3x, 2x times 5 gives me 10x. These two come close, but they don't add together to give me that 11x. So that's not the solution because these two like terms don't combine to give me that middle one. Let's try again. That's why it's organized guess and check. Leave that there, don't erase it. Just set up another box to say, okay, let's try something else. Let's leave the 2x and the x here for that. Now let's swap the 5 and the 3, have them switch places. So I'm going to put a plus 5 here and a plus 3 here. X times 5 gives me 5x. 2x times 3x is going to give me 6x. These two do add together. When you add this one to this one, you do get that 11x in the middle. So we now have the factorization because this 2x plus 5 and this, the x plus 3, those, if you were to double distribute it out and combine like terms, you would get that 2x squared plus 11x plus 15. So notice the key to this is, just like here, we separated out the middle terms. Finding out what those middle terms are, this is more strategic in figuring out what the grouping is. This one's more just a guess and check and organizing your factors in order to see which ones work. Let's go ahead and try now doing it again with these down here. Okay, so let's start with this one. Now, looks like we have a greatest common factor. Not the numbers, but there's an x in each of these that we can factor out. So we should take out an x first, GCF first. Okay, so that's my GCF. Now, don't worry about this x right now. We're going to focus on this trinomial to factor. So take the GCF out and then focus on the trinomial in here. I'm going to do the x method here. Now 4 times that negative 21 is negative 84. That's a really large negative number. You got to recognize that there's going to be a lot of factors for that. Bring the 8 and just put it down here. So I'm looking for two numbers that multiply to get negative 84, add together give me 8. Well, there's a lot of options here. I could do negative 84 times 1. That doesn't add together give 8. I've got negative 42 times 2. Still doesn't add together give 8. Negative 21 times 4 gives me that negative 84. Doesn't add together give 8. Let's see, I could do, I could try a couple other options. Negative 12 and 7 multiply together give me negative 84. Those don't add together give me the 8. Now I'm going to come close here. Negative 14 and 6, those multiply together give me negative 84, but they add together give me negative 8. When that happens, then just swap where the negative is. So I'm going to make this negative 6 times the 14, and that will add up together to give me that 8. So now I could have negative 6x, and I could have here positive 14x. Let's go ahead and rewrite this. I'm going to keep the x out here. Leave the x, actually just leave the x off at the end. Just remember that it needs to come down to the final answer. Let's just focus on this trinomial for right now. So 4x squared, I'm going to make it minus 6x plus 14x, and then minus 21. Okay, so I separated out this 8x into negative 6x and 14x. Now look for common factors in these. I'm going to take a common factor here. I've got a 2, and I've got an x I can take out. When I take the 2 out, I'm left with 2x. When I take a 2 out of this, I'm left with just a 3. Now on this one, I can take out, I've got a 7 in common between the two of those. So take out a 7, you're left with 2x, and then minus 3. There's my secret. Notice there's a common binomial factor in the two of them. I'm going to factor that out, and I'm going to make it 2x minus 3 factored out. And what am I left with? 2x plus 7 left over factored on the inside. Now, if you notice, I still need to bring this x down, so bring it down as part of my factorization. That's what this trinomial factors into using the x method. All right, now let's use the box method on this one. So the box method, remember, there's no GCF, so look for that first. So I'm going to put a 6x squared here and a minus 5 here. Well, 6x squared could be 6x and x. It could be 3x and 2x. So don't use the negatives on the first term. We'll use it on the last term. So what I'm going to do is I'm going to use 3x and 2x. It's really a choice. If it doesn't work with the one that you do choose, you're just going to have to keep going and try the next one. All right, I'm going to try for this negative 5, could be negative 5 and 1. So let's try that, negative 5 and positive 1. Let's see how that does for my middle term, right? So 2x times negative 5 is negative 10x. 3x times 1 gives me a positive 3x. Lo and behold, we just happen to, on our first try, get this one. So we don't have to try another box to do it because these two combine to give me that negative 7x. So my factorization is 3x minus 5 and 2x plus 1. So we've got two methods now for doing all trinomials. Now if the leading coefficient is 1, I recommend using the shortcut that we learned in the other video, but for this one, this works for all of them. You can either use the X method or the box method. The X method gives us a strategic way to group them and then use the GCF to factor out to get our final answer, whereas the box method just is an organized way to do guess and check, but to come up with your answer by trying the possibilities until you get those middle terms to match. Therefore, what we do is to factor trinomials, make a decision of which method you prefer out of these two, and then learn and practice with your different trinomials on how to factor.